Hello, hello. We're going to talk about Chapter 5 in geometry, or at least we're going to get ready for it, says the title screen. Chapter 5 deals with triangles just like Chapter 4 did. But one of the things that we really need to feel comfortable about is the verbiage that we use, the vocabulary, and the types of triangles that we're going to deal with. There's two ways to categorize triangles, by side and by angle. On the left here, we have all of the names of the triangles based off of their side. We have what's called an equilateral triangle, where all three sides are congruent. Fun fact, if you have all three sides that are congruent, all three angles are going to be congruent, and to be specific, they're all going to be 60 degrees. That's when we call it an equiangular triangle. Oh, that was neat. Fun fact. Lots of fun facts for the equilateral triangle. Equilateral, equal sides. An isosceles triangle has two sides that are the same. Those two sides that are the same are called legs. The side that's not the same is called the base. Another fun fact about the isosceles triangle is if you have two sides that are the same, then two angles are also going to be the same. Those are called the base angles. The angle that's not the same is called the vertex angle. So much to remember, so much to do, so much to see, so much wrong with things in the backstreet. I think that's Smash Mouth. But not so much about scaling. Scaling, all the sides are different. Nothing crazy to remember, just all the sides are different, baby. All different sides, which means all different angles, nothing's in common. Okay? Now let's move over to naming triangles based off of angle. In an acute triangle, every single angle is less than 90 degrees. That's an acute triangle. Acute triangles can be equilateral, they can be scalene, they can be isosceles. So don't be like, oh, if it's one, it has to be the other. No, no, no. A right triangle has one angle that is 90 degrees. Since triangles contain only 180 degrees of angle in its angle sum, you can never have more than one 90-degree angle. Similarly, you can never have more than one angle that's greater than 90 degrees, and that's where you get your obtuse triangle from. An obtuse angle is greater than 90, so an obtuse triangle has one angle that's greater than 90 degrees. The right triangle has one angle that is 90 degrees, and the acute triangle has all three angles less than 90. So we're going to use these words a lot in this chapter. Make sure if I were to be like, blah, 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 obtuse triangle, you're like, I know what that means. So let's actually talk about angle measurements and how we can name specific triangles based off of that. This first triangle I have has this angle that's 61, that angle that's 63. So what's that angle going to be right there? Oh, I know. It's going to be the remaining angle measurement from 180. 180 minus 63 minus 61 is... Well, she didn't say it out loud, but she says 56 to me. So look at that. All three angles are different, which means all three sides are different. So see how these have tick marks, and that has 1, and that has 2, and that has 3? That means this is scalene. And the fact that all three angles are different is also scalene. But more important, all three angles are less than 90, which means this is scalene acute, or acute scalene. I'm not sure the order in which we should put that to make it sound better. An acute scalene triangle would probably be better, but I like scalene acute. Oh, look, a right triangle. So I have a right triangle, because there's a right angle is what I meant to say. Ooh, and these angles are the same, which means these sides are the same, which means we have isosceles. I never remember how to spell isosceles. I think that's it. I don't think there's an E at the end. I think that's right. Now, there's many ways that we can find out missing angles. And in this case, I use the interior angle sum theorem, where all three angles add up to 180. The other thing that we're going to have to remember is if I give you a straight line, bada bing, and I cut that line with another line, those two angles add up to 180. I'm going to have to remember that. I'm also going to have to remember that vertical angles, like that guy and that guy, are going to be congruent. So I'm going to take this knowledge and I'm going to find the missing angles of a triangle. Let's start out with a ramp. A ramp makes an angle of 9 degrees. So there's that 9 degrees right there. You can't see it with the ground. What is the measure of the missing angle in the ramp? Well, that is 90. That's 9. So I have to find that one. So I'll call you, I don't know if it has it looks like it's a question mark. So I'll make that a question mark, plus my 90-degree angle plus my 9 is all going to add up to 180. So question mark plus 99, ooh, that's how many problems Jay-Z had, equals 180 minus 99 and that missing angle is going to be 81 degrees. Now, some of you might be like, I could have done that faster, Mr. Perich. I could have done 180 minus 9 minus 90. You're absolutely right. Or you could have been like, well, since that's a right triangle, I only care about 90 degrees, and so 90 minus 9. You're absolutely right. So many ways to solve a triangle. So many ways to get the job done. Find the missing angles. Well, let's try to remember the picture that I drew. Oh, I remember one of the pictures. When you have a straight line, like I do here, connecting 1 and 120, and I cut that line with another line, those two angles that are created by this diagonal-looking line add up to 180. So angle 1 plus 120 equal 180. If I subtract 120 from both sides, the measure of angle 1 is going to be 60 degrees. Not bad. So I can erase that and make it 60. Ooh, and now I have two angles within a triangle and a missing angle, which means 55 and 60 and angle 2 add up to 180. Angle 55, angle 60, and missing angle number 2 add up to 180 degrees. So those guys add up to what? 115. 115 plus angle 2 is going to equal 180 minus 115 minus 1. Oh, wrong one. Silly me. Minus 115. Angle 2 gets me 55. Now, some of you might be thinking, wait a minute, sir. Isn't there an exterior angle theorem that says 120 equals 55 plus 2? Yes, there is. And that's how you could do that one as well. And I screwed up. This is actually not 55. It's 65. Boy, is that embarrassing. So you could set this, the exterior angle theorem says that the exterior angle 120 is equal to the sum of the, there's a word for this and I can't believe I forget what it is. Something interior angles. I can't believe I forget that first word. But if you add the opposite interior angles, I don't think that's right. 120 equals 55 plus 2, and so I would just subtract 55 from 120 and still get 65. It would work out. That's just another option. So many options to do these triangles. Like I said before, I'm not a liar, except for when I write out wrong math. Find all the missing angles. Ooh. All right. I think I will start with 6. That's just what I'm going to start out with, 6. Why 6? Because 6 is an angle living inside of a triangle. So the measure of angle 6, and I'm going to go easy on this one, 180 minus 107 minus 43. $180 minus 107 minus 43.
It's 30.
So you're done. Let me think. Ooh, this is the exterior angle thing that we were just talking about. Oh, I can't do that yet. 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 So if you're 30, ooh, watch me be clever. You ready? You watch me be clever. 6 is now 30. So I'm going to try to cover that. Look at this guy right here. I'm creating one big triangle by doing this. One big triangle where I have, I don't know, and then this angle is 100, 70 plus 30, and this angle is 43. So 180 minus 70 minus 30 minus 43.
It's 37.
So you are now 37. Ooh, my age. I am missing 5, so that's 37, that's 70. So 5 is going to be 180 minus 37 minus 70.
The answer is 73.
Ooh, 4 is vertical to that, which means 4 is the same. This is weird. We haven't dealt with this yet. An entire circle makes 360 degrees. So let's be careful. 2 is going to be 360 minus 73 minus 107 minus 73 minus 65.
It's 42.
And you know what else I could have done? 2 is going to be 180. So if you see right here, 2 is attached to a straight line right here. So I could also do 180 minus 73 minus 65. That would also work. So what? 2 became 42. 2 became 42. And I will finally use that exterior angle theorem and say that 3 is the same as 42 plus 90. And 42 plus 90 is 132. Ding! Okay, so I think we have one more problem. We do. And it's actually not that bad. Find x. A, B, B, C, and AC. Okay, so I'm finding x and I'm finding the length of each side if ABC is an equilateral triangle. So I know with equilateral triangles, two sides are going to be exactly the same. So if two sides are going to be exactly the same, I can set two sides equal to each other. So I'm thinking the easiest ones to do are, let's set 8x, the bottom side, equal to 7x plus 3, the right side. Why am I doing this? Because if I subtract 7x from both sides, that gives me x equals 3. And so I now have x. X equals 3. So how do I find the length of each side? Substitute x with 3. 8 times 3 is 24. All of these are going to be 24 because they're all the same side. But just for fun, 7 times 3 is 21. Ooh, 9 plus 10. 21 plus 3 is also 24. And last but not least, 10 times 3 is 30. 30 minus 6 is 24. Look at that. I did it right. Okay? So that should adequately prepare you for Chapter 5 in geometry. That's it. Bye.